The human consequences of climate change will include more food insecurity, reduced crop yields, increased migration, and dramatic damage to coastal communities, including to large cities such as New York, Calcutta, and Shanghai. But will climate change lead to more armed conflict? Climate conflict links have become a major subject of both conjecture and analysis. The scientific literature on climate change and security threats, principally armed conflict at multiple scales, has proliferated rapidly. A quick and dirty assessment of Google Scholar Index studies suggests that in 2003, links between climate change and conflict received less than 10% of the attention of terrorism, the defining security concern of that moment. By 2018 and 2019, it was at relative parity, reflecting a large shift in scholarly interest. This interest has been catalyzed by two dramatic events that seemingly illustrate strong climate conflict linkages. Beginning in 2003, the world was witness to a civil war and subsequent episodes of ethnic cleansing in the Darfur region of Sudan, which had been buffeted by desertification, drought, and increasing scarcity of arable land. Some years later, UN Secretary General Ban Ki-moon would identify the Darfur conflict as the first climate war. In the 2010s, a similar discourse has sprung up around climate-fueled drought, urbanization, and the outbreak of the Syrian civil war, which is perhaps the defining humanitarian crisis of our time. President Obama said climate change-related drought helped fuel the early unrest in Syria, which descended into civil war, while Secretary of State John Kerry noted it's not a coincidence that immediately prior to the civil war in Syria, the country experienced its worst drought on record. Now, despite these claims, the relative role of climate change and climate variability in threats to peace and security, like armed conflict, has been hotly contested, with competing claims about the strengths of impacts, the mechanisms by which these impacts operate, and their causal weight relative to other well-known and extensively researched drivers of conflict. The remainder of this talk is built around a recent expert elicitation exercise on the subject, published in Nature last year, led by Catherine Mock at the University of Miami's Rosenstiel School of Marine and Atmospheric Science. This exercise helps to shed light on the emerging consensus regarding climate impacts on conflict, but also provides an opening for discussing the adversarial model of scientific discourse, and whether that model serves the needs of policymakers, national security practitioners, and society more broadly. Before returning to the findings of the expert elicitation, let's talk about why it might have been necessary. To do so, we'll contrast two modes of scientific discourse, or the way a given scientific community structures its interactions to produce shared knowledge, including norms around interactions, evidentiary standards, and ethical conduct. The dominant form of scientific discourse is adversarial. Think of this form of discourse as a boxing match, in which the boxers are the scientists or teams of scientists, the referee is the review process, and the judges are the wider scientific community. Only in this boxing match, there are few, if any, true knockouts, or decisive findings that irrevocably put the matter at hand to bed. There are only wins on decision. The collective assessment of the wider scientific community decides who wins and who loses, and there are constant rematches. For our purposes, the most important implications of this mode of discourse are two. First, it structures discourse according to the adversarial logic of debate. The goal is to win, or to have the last word. And since scientists are flawed human beings with personal pride and egos and reputations at stake, we tend not to take too kindly to losing. We are often the last ones to concede. Second, the adversarial mode of discourse incentivizes the accentuation of disagreement and the taking of clear, unambiguous positions on complex issues. Two scholars or teams of scholars might agree on 98% of the relevant facts and issues under discussion, but their interactions will revolve almost entirely around the 2% over which they disagree, often vehemently. Let's look at a concrete example, built around the work of Marshall Burke and colleagues, on the one hand, and Halvard Buhaug on the other. It will later become clear why I'm focusing on their interactions. In 2009, Marshall Burke and co-authors published Warming Increases the Risk of Civil War in Africa in the Proceedings of the National Academy of Sciences. Their study found strong links between civil war and temperature in Africa, with warmer years leading to significant increases in the likelihood of war. On the basis of their results, they extrapolated that rising temperatures would result in an additional 393,000 battle deaths in civil wars by 2030. 1 year later, Halvard Buhaug published a response in PNAS entitled Climate Not to Blame for African Civil Wars. Using different model specifications and alternative measures of drought and heat and civil war, he concluded climate variability is a poor predictor and not a robust covariate of armed conflict, with well-known drivers like ethnopolitical exclusion, poor economic performance, and the collapse of the Cold War system more plausible explanations for the observed patterns of violence. We'll score that round 10-10. Later that year, Burke et al. Countered with climate robustly linked to African civil war. This salvo was followed by another response from Buhaug, with the tenor of each piece growing increasingly defensive or offensive, depending on your point of view. And perhaps the analogy would have been better to a professional wrestling, because at this point onlookers began running into the ring with commentaries on both camps' methodological choices and conclusions. Now, imagine you're not a social scientist working in this area. Imagine you're working in the DoD or the intelligence community, and you're asked by your superior, is climate change going to lead to more conflict in Africa? You resort to the literature. Getting there, your response might be threefold. First, confusion. A lot of the debate ultimately revolves around seemingly arcane choices about model specifications and specific econometric techniques that may or may not be understood by the analyst, who certainly doesn't have as much time to spend in the weeds as the scientists themselves. Second, the perception that there is a very strong disagreement here and a lack of consensus. And third, likely disengagement. If the answer isn't clear, the scientists either don't know or it isn't actionable. This is why Harry Truman famously, and most likely apocryphally, wanted a one-handed economist. The whole reason to have technical advisors is to help boil complex issues down to straightforward, assertive recommendations or statements about what will happen as a consequence of action or inaction. Given the ambiguity actively fostered by this adversarial mode of discourse, what does this mean for policymakers seeking technical expertise and advice? Typically, policymakers will not have the time or desire to convene all relevant experts and hear them out. There is some process by which the universe of potential experts is winnowed down to a tiny fraction of the relevant pool of expertise. And if we're being honest, that winnowing process often is driven by highly idiosyncratic factors that have little to do with whether the expert is objectively correct or even representative of scientific consensus. So who gets into the room matters. If it's Marshall Burke, you might get one answer. If it's Halvard Buhaug, you might get something decidedly different. And this issue is exacerbated by academic seniority and thus perceived expertise. My team's survey work on international relations scholars' policy engagement activities finds that nearly half of chaired professors value the conclusions of their own research over the scholarly consensus on an issue when discussing these issues with policymakers. Only 20% of those chaired professors express deference for scholarly consensus over their own findings when discussing those topics. And why not? After building successful careers under the adversarial model of scientific discourse, why wouldn't they stick to their guns? There are alternative models that might be helpful for informing the wider scientific community and policy audiences, especially when evidence is ambiguous, complex, or incomplete, but decisions need to be made sooner rather than later. An integrative model of discourse takes the metaphorical boxing match that is the adversarial model and turns it into something more resembling a mediation exercise. In this model, the mediator, that is, the elicitor, convenes groups of scholars to discuss the state of knowledge and diverging perspectives around a given subject. The goal is not to win, but rather to identify areas of consensus and disagreement. Further departing from the adversarial model, the focus is on broad questions or topics, rather than on individual scholarly contributions and debate. Thus, it depersonalizes the discourse to a much greater degree. This model is less prevalent, in part because it is very resource and time intensive. Expert elicitation is one such integrative model. Expert elicitation is a well-vetted method for documenting the judgments of experts about available evidence. For relevant topics with divergent evidence, individual elicitation, that is, structured intensive interviews with each expert, followed by a group-wide discussion of the results and collective reassessment of the evidence, can better reveal the state of knowledge than either of those approaches in isolation. This brings us back to the Nature article. To assess climate conflict links, Catherine Mock and her graduate student, Carolyn Cron, impaneled experts from the fields of economics, environmental studies, political science, and geography to assess the state of knowledge around these questions. Notably, the two heavyweights who squared off in PNAS, Marshall Burke and Halvard Buhaug, were among them. They conducted structured interviews with the experts, which were followed by 2 days of deliberations around consensus points, gaps in knowledge, and discussions of paths forward. Catherine Mock, the elicitor, approached the subject by trying to mine these different positions for consensus, building on shared ground in an inclusive, face-to-face, deliberative process while still acknowledging ongoing areas of disagreement. Regarding the motivating questions, what is the contribution of climate change and climate variability to armed conflict, and how important is that contribution relative to other known drivers of armed conflict, the ultimate answers arrived at over 2 days and 900-plus pages of transcribed interviews were, historically, not very large, and not very large relative to other known drivers, but anticipated to get significantly larger under plausible climate change scenarios. These key figures highlight the main results. Figure 2 presents the main findings, with average assessments for the different scenarios presented as solid circles, and the experts' various assessments as hollow circles. The assessment? In the post-World War II era, the consensus was that climate change and variability had substantially increased conflict risk by about 5%. But, under a 4-degree warming scenario, that risk could increase fivefold to 25%. Figure 3 puts the risk contribution of climate change and variability for past conflict in context with other well-known drivers of armed conflict. This figure demonstrates that conflict risk associated with climate change is relatively minor when compared to factors like low socioeconomic development and poor economic performance, low state capacity to provide services and security, high levels of intergroup inequality, such as political and economic inequalities between ethnic or religious groups, and spillovers from neighboring countries. Moreover, it shows that climate risk is, among the listed drivers, the one for which the evidence is most uncertain. The article obviously goes into significantly more detail about causal channels and mechanisms and characterizing uncertainty, but these were certainly the clear consensus positions. And these results are a lot more legible and easily communicable to policymakers than the conflicting literature that undergirded the exercise. Elicitation is not a panacea. The composition of the experts is a function of the state of the literature, which resulted in no representation of perspectives from Global South scholars. Moreover, it's quite resource-intensive in terms of time, travel, and cost. If funding agencies and policymakers want this kind of work, they will have to adequately support it. This talk has used a recent expert elicitation exercise as a means of assessing the contributions of climate change to armed conflict and demonstrating how integrative, rather than adversarial, modes of scholarly discourse can help inform policy decisions under conditions of fundamental uncertainty and a pressing need to prioritize and take action. And climate change is clearly such an issue.